So in last session, we have studied some basic theory of the sheet metal. So now in session, we will try to complete this sheet metal module. Okay. So it's a very simple, here we don't need to create a sketch. Okay. Here we have to just to add flange, to assign bends, to assign hole, fillet, chamfer. Okay. Already we studied in part modeling, but here we have to just apply. Okay, so what we studied, so what is meant by sheet metal and how up to from which range to which range we call this the sheet metal. Okay, so first question is how much thickness we required for sheet metal?
0.4 to 6 mm.
Right. So from 0.4 to 6 mm we require the sheet metals. So up to this one we call the sheet metal. Okay. Then from 6 mm to 12 mm or 16 mm we call it as a plate. Okay, it's a plate. It's not, sheet metal is nothing but you are the one of the plate, but in small scale. It's from 0.4 to 6. But in industry, mostly from 6 mm to 16 mm, okay, or 18 mm, we call it as a MS plate or SS plate. So now we will create out the sheet metal first plate. It's a base plate. So for I will ask, convert units into millimeter, activate planes. Okay, then click on sketch and select your required plane. I will create one rectangle. Okay, so suppose it's a 150 by 150 by 80. Okay, I exit from sketch. So now I have this sketch. Okay, now I want to assign my first command. Which one? So go to sheet metal and select on base flange. Base flange is nothing but to assign a thickness, okay, bend allowance and relief. Okay, but if your first sketch is a plane, so you can't assign relief. Okay, so I'll select a sketch. So here you will get a sheet metal thickness, bend allowance and relief. So if I want to assign the 2 mm thickness, I'll click on here. Okay, if you want to change the direction, okay, top side, bottom side, see. Okay, and if I click on OK. So now I assign it to mm sheet metal thickness. Now I want to add one of the flange. Flange is nothing but your extra plate which consists bend. Okay, so here you will get a edge flange. Okay, so what is the selection here? Here you have to select edge. Okay, in name you will get a selection. It's an edge flange. So I will select on edge. So that you will get here a edge flange. So here already we studied which one is activated. It's a bend outside. If I click on material inside, okay, if I remove this offset, okay, I will remove this offset. So now bend will start from inside. So here bend will start from outside, but from outside. Okay, so if you see this edge, okay, it's a new edge or new flange. If I extend this one, so you will touch up to this edge. Okay, then bend outside. Okay, so now bend will start from outside. If I click on bend from virtual shaft, okay, so during exercises I will show you what is this one. Okay, so after this one, just remember inside, outside and which one? Material outside, material inside, and bend outside. Okay, so this one. Here we have this height. Okay, but here we have the three options. Which one? Virtual, outer virtual sharp, inner virtual sharp, and third one, tangent bend. Okay, so if we select on here, it, outer virtual sharp. Okay, so the outer virtual sharp means, okay, now what is the difference between outer virtual sharp and tangent bend? What is the difference? So here it's a outer virtual sharp will starts from your bottom edge. Okay, you will start from the bottom edge, and in tangent bend. Okay, so if I create a line which is tangent to this edge, okay, if I create a tangent to this, so from this tangent or this imaginary line to top up to this one, you will get a height. So this one is your tangent bend, and here it's an inner virtual sharp. Inner virtual sharp assign the height from this after completing your bend. Okay, so this is the starting and this is the end. So height will assign from this line to this height. Okay, so these are the some differences. Now, if you want to change the direction, okay, so you can change. At the time, you can select n number of edges. Now, okay, so here I already select one edge. If I select this edge, okay, so you will get another edge. Now, if you want to change direction, okay, if you want to change direction, just click on arrow. Okay, just click on the arrow, so that you will get a direction change. Okay, now if I click on OK, so that you will get a such a shape. Okay, but I don't want to create a flange from starting from this point to opposite point from this point. Okay, I want only in middle portion. Okay, I want only from this point to this point. Okay, not in opposite in this direction. So what I'll do, I'll go to edge, click on edit feature. So here you will get option edit flange profile. These options you will get in miter flange, hem, jog. Okay, so you will get these options in this. What is the option? Okay, I will delete one of the edge. Okay, so I will keep only one. Okay, so now if I click on edit flange profile, okay, so here you will get another window. Okay, here you will get another window. So what you will get here, you will get a one rectangle. Okay, you will get a one rectangle. Here you will get a blue line, and this lines you will get a black lines. Means you cannot change this black lines. Okay, you have the option to change only blue one. So I will reduce this. Okay, so if I just pick bottom point, okay, and from this side and from this side, okay, so that you will get a So if I see from the bottom now, okay, so that you can change the position. Okay, you have the option to assign a distance from this edge to this point. Okay, so from this point to this point, I want to assign a distance. Suppose on 30 mm distance, I want to start my flange. And in opposite side, suppose I want to assign a gap from this point to this edge or point, suppose 20 mm. Okay, so then you will get this one. Now, if I click on back, okay, if I click on the finish, so the you will come outside of your command directly. If I click on back, okay, if I click on back, so still you are in command. So here you will have the option custom relief type. Okay, custom relief type. Okay, so here we have the relief types. It's oblong, rectangular, or tier. Okay, we have the three types. So if you see here, you will get such a cut. Okay, so this one is a rectangular cut. Okay, if you see, this is the starting point. Or if I click on OK, okay, so you will get this cut. Okay, so this cut is a rectangular cut. If I go to again edit option, go to drop down and select here oblong. Okay, so here you will get a curvature. Okay, here you will get a curvature. If I go to tier, okay, so if I click on the tier, you will not get any cut. Okay, means you will not get a rectangular or oblong type cut. Okay, it just if I cut the plate from this edge and just bend. Okay, so if you see, you will get a straight cut and you will get a such option. Okay, so this is the difference. Okay, so now tell me why we require the auto relief or these relief types. Okay, if I click on now OK, so now if I see from the top side, okay, so here you get a oblong type. In opposite side, you will not get any tear. Why? Because it's a bend will start from edge to edge. Okay, when you will get a tear, when you have the extra material, so you will get a this extra relief. Okay, means if I start bending from inward, okay, from inside, so in this condition you will get only the relief. Okay, relief we required for reducing the stress concentration during cutting or bending. Okay, if you can't provide proper relief, okay, so that you will get some distortion edges. Okay, some deflected edges you will get during your bending or cutting. So avoiding for such a defects, we required reliefs. Okay, so this one is the edge flange. Next one is the mitral flange. Okay, I will remove these flanges. Okay, now I will click on the mitral flange. Same, I will select the edge. Okay, same here we have to select the edge. Okay, in mitral flange, what we required? We required a profile. Okay, we required a profile, which is we have to create. Okay, if you see a message, a planar face on an edge, which to sketch the features, it's a cross section. Means, suppose I want to flange in this direction on this edge. So in this case, what we required? We required to create a sketch which is perpendicular to this edge. Okay. So for this edge, which is perpendicular, this surface is perpendicular. So I will select this perpendicular face. Now I will create a profile. Okay. Now you have to create such a profile which is tangent to each other. Means initially you have to create the bend. Okay. You can create a bend. So this one is bend. But what is the condition? This bend or this arc must be tangent to this edge. Understood? Okay. This edge or arc must be tangent to each other. Now, next I will click on the line. I will create a one line. Okay. Same, this line and this arc must be tangent. Okay. So for miter flange, we require such a condition. So now again, if I create an arc, okay. If I create arc, now I'll click on the arc, control button, and this line. So I'll click on here tangent. Okay. So now I have this profile or cross section. Okay. I have this cross section. So now I will go to sheet metal, click on miter flange, and click on this sketch. Okay. So when I click on this edge, so that you will get such a profile. Okay. So same thickness you will get. It's a 2 mm thickness you will get here. Okay. And if I click on OK now, so that you will get such a shape. So now you have to create such a profile which is tangent to each other, but on this edge. Suppose I want this profile on this edge. So I will create a profile which is perpendicular to this edge. So I select this one. Now if I go to again miter flange, okay, and here if I select a start or end offset, okay, means from this point to this point I want to assign the distance. Okay, I don't want to start my bend from this edge, so that I will select or assign a gap. Okay, similarly in opposite side. Okay, so that you can create such a profiles. The next one is a hem. Okay, in hem you will get a number of types. Okay, we have here 4 types. Okay, if I click on the hem, so here we have the types and sizes. First one is a closed, second one is open, third one is teardrop, and fourth one is a rolled. Okay, so I will click on the first one. It's a closed, and in edge, if I select this point or this edge, okay, so this one, which one is a close? Close means you will get a bend, okay, and a tangent line, okay, bend and this tangent line. Same, you will get a 2 mm thickness. Here you will get a gap, okay. This gap is depends on your bend, okay. Bend means if you see this one, you have to maintain this gap, okay. So you cannot change this radius, okay. Software by default applies this radius, internal radius. Now if you want to change this length from this edge to this edge, so we have the option, okay. So from this one 30 to 40, suppose I want to add increase. Okay, if you want to change direction in bottom, top, right, here we have the option bend outside and bend metal inside. Bend outside means, okay, so in actual we have the metal from this surface to this surface in opposite surface. But if you see the bend, okay, so bend is starting from inside. If you click on the outside, okay, so the bend will start from this surface. Okay, same, I don't want to create a flange from starting to end. Okay, so from this starting to this end, I don't want to create a this flange. So I'll click on edit flange profile, and I will assign the, okay, click on the back. Sorry. Okay, okay, so the same options. If you click on the custom relief, so you will get a rectangular relief. If you want to change obron to tier, you can assign. Okay, so such a you will get a closed one. Same if I click on open. Okay, so this one is open. Open means now here we have the option to maintain the gap. Which gap? From this surface, okay, from this main bottom plate to top one. If you see the gap, if you increase the distance, okay, if you increase the distance, you will get a gap. If I want to assign a 5 mm gap from this edge to this edge, okay, I want to assign the gap from this edge to edge. So this one is a 5 mm. Here you will get, if you want to increase this bend, sorry, not a bend, this extended flange. So I will click on the distance. Okay. Second option is a teardrop. Okay. If I click on the teardrop and if I want to increase the, okay, so this one is the radius. Okay. If you see this radius, it's if you see this arc. Okay. So for this arc, we require the radius. It's a 10.5. You cannot change now the length. Here we have the option to degree. Okay. It's a degree. If you increase the, okay, if you increase degree, you will get a, okay, so this one is the radius and this one is the degree. Most of the time you have seen such a profile in hinges. Okay, so if I remove this metal flange, okay, so such a profile you will get in hinges. If you see a door hinges, okay, so such a parts hinges are created by using the this hem command. Okay. Then in next one is the rolled. Okay. So in rolled, what we have the radius and degree. But if I click on the opposite edge, okay, if I click on and if I increase the radius, okay, and if I increase the degree, so what is the difference between now? Okay, what is the difference between now? Not this, right? Okay, now if I increase the degree, okay, so he will create in rotation or in complete arc. Okay, but in this teardrop, you will get a, okay, you will get a some portion of the straight flat surface and some portion of the radius. Here you will get a complete radius, okay, but in round, not a straight line. If I now click on OK, so the you will get a such a portion. Okay, so these are the hem types: open, closed, teardrop, and rolled. So mostly uh, we require it's open or teardrop. Okay, open and teardrop we mostly use. Okay, because of these are the very easy to manufacture because of for bending or for radius. Okay, it's a very difficult to maintain this radius, complete radius in rolled. Okay, so these are the hem options. Now next one is the cross break. Okay, so this is not a one command. It the meaning of the cross break is it's a graphical representation of cross break in the sheet metal part. Okay, means he will add only a cross symbol on your sheet metal. Okay, he will create a cross symbol. If I click on the cross break, okay, if I click on the cross break and click on the surface, okay, and click on OK now. Okay, so here you will get a this symbol only. Okay, nothing there. Okay, this one is a close symbol. The representation of this cross break is useful for the ducting. Means for I don't want to assign a new feature or new manufacturing process on this surface. Okay, I don't want to create a bend, hole, okay, or any other manufacturing process on this portion only. So the I will assign a cross break. Okay, so this will represents your a cross. The next one is the sketch bend. Okay, so before that, here after cross break, you will get here a flat pattern command. So now what is meant by flat pattern command? Now, suppose I want to create this object. Okay, मुझे क्या करना है? मुझे ऑब्जेक्ट क्रिएट करना है. बट इसके लिए मुझे कितना शीट मेटल लगेगा फुल लेंथ. ओके, ये मुझे फाइंड आउट करना है. ये पार्ट बनाने के लिए आई वांट टू क्रिएट अ सच अ पार्ट बट आई डोंट नो हाउ मच शीट मेटल, okay, length into width. I don't know how much are required. So in such a case, we have to first flatten this your complete object. Okay, flatten a complete object by just click on flatten option. Okay, so here you will get option flatten. Okay, so if you see for creating my main object, okay, main object, I required, okay, I will go to evaluate, measure from this edge to this edge. I required length. Okay, so this one, which one? Okay, this one. Okay, so it's a 181.16 mm. I require the length. Okay, and in from this edge to this edge, okay, I required 150. Okay, so it's a representation of the how much sheet metal required for creating my final object. Now, if I click on again, go to sheet metal, and if I click on again flatten, okay, so you will get your original object. Okay, so here you will get your original object. Simple, yes. Okay, then okay, so hopefully you understood what is my flat command. But I don't want to create a complete flatten command. Means I want only okay, what I will remove this cross break, or I will remove these two hems. Okay, and if I click on edge flange and assign two different flanges. Okay, in opposite side, one in top side, one in bottom side. Okay, so I create this one, but I want to a distance from this point or from this surface to this surface, means the addition of these two flat surfaces. So in such cases, I have to unfold. Okay, so it's already folded. Okay, so initially I have to unfold this bended portion. So I'll click on here a unfold command. Okay, here fixed face. Which face you want to keep it as it is? So I want this one as it is. Bend to unfold. Which bend you want to unfold? This bend. Okay, if I click on collect all bends, so the software will select this bend also. Okay, सॉफ्टवेयर क्या करेगा, ये बेंड भी सिलेक्ट करेगा, बट मुझे ये बेंड अनफोल्ड नहीं करना है. मुझे क्या करना है, ओनली अनफोल्ड दिस पोर्शन. सो आई क्लिक ऑन एज बेंड एंड सिलेक्ट दिस वन. Right, now if I click on OK, okay, so see, you will get this one is a straight or bended portion and this one is the your flattened. Now you can measure. Okay, now you can measure from this edge to this edge. Okay, so here it's a red portion or red line represents it's a horizontal line. So this one is a 186.99. It's a flattened distance. Now, okay, now if I go to again sheet metal, and if I want to fold this one again, okay, but I don't want to delete this unfolded command. Okay, I don't want to delete, still I want to fold this one. So I'll go to here, fold command. Okay, same. Now software will select your fixed face by default. Okay, which one you have selected in unfold? Okay, software will select. सॉफ्टवेयर क्या करेगा, आपने अनफोल्ड में जो फिक्स फेस सिलेक्ट किया है वही फेस फोल्ड में सिलेक्ट करेगा, वो बाय डिफॉल्ट करेगा. यहाँ पे आपको सिलेक्शन का ऑप्शन नहीं है. नाउ यू कैन असाइन दिस एज. Or okay, so this portion work as a bend. If I click on OK now, so that you will get a this bend again. So here you will get a unfold and fold. Okay, if I just pick this horizontal line and just drag up to this point. Okay, so means from this is our main base flange, then we add this flange. If I drop down to bottom, you will get a second flange. If I drop down it, you will get this unfold command, then again fold one, and in the last you will get a flatten. Okay, but this one, if you want to activate this one, just click on this flatten command, so that you will get a total flat bend, sorry, flat sheet metal. Okay, hope so you understood. It's a very simple. Okay, now on this flat surface, I want to create, okay, I want to create a hole. Okay, I want to create a hole. So what I will do, I will just select a simple hole command. Okay, select a simple hole command and click on this surface. Okay, by default you will get here a circular one. Okay, here you will get a by default circular, because it's a hole. If you want to cut hexagonal, rectangular, polygon, ellipse, okay, for this one you have to go to extruded cut command. Okay, I will show you. Okay, so now, so for this one, how much the diameter is a 10 mm. Then it's a depth. Okay, so we have here a 2 mm sheet metal. I want to cut only a 1 mm, or I want to create a 1 mm hole. Okay, and if I click on OK now, if you see, okay, so you will get a this hole. If I go to again edit option and assign 2 mm depth, okay, and click on OK, so that you will get a throat hole. But I want to create now, or I want to cut square, rectangular, polygonal, or any other irregular shape. So in such cases, what I'll do, I'll go to sketch, select surface, and create a irregular shape. Okay, now exit from top. Now I want to cut this portion. So what I will do, I'll go to sheet metal and select here extruded cut. Same commands or same features you will get. Already you have used in part modeling, in even in assembly also. Okay, so if I click on the extruded cut and select on this sketch. Okay, I want to depth, it's a 2 mm. Okay, same you will get a direction 1, direction 2, selected contour, same. Okay, now next thing is I want to cut. Okay, I want to cut a 50% rectangle on this vertical sheet metal and 50% on this horizontal sheet metal. Now, what I have to do? I want a 50% cut, rectangular cut on this vertical sheet metal and 50% on horizontal. So what we have? Okay, if I click on now sketch, okay, so sorry, I'll exit from this one. Okay, so what I will do, I will first flatten this bended portion. So again, I will go to sheet metal, click on unfold. Okay, click on unfold. Click on I want to this fifth one and unfold this bend. Okay. So now next one is okay. Again, select this surface and click or create a 50% rectangle on top side and 50% on bottom side. Okay, so it's on I create a approximate. Now exit from sketch, go to sheet metal, select extruded cut, and I will cut this portion. Okay, now I will fold it again. Okay, so here if you will get a by default fixed face, and this one is the bend portion. I click on OK. So now if you see, you will get a such a cut. Okay, understood what we did? What we did, we just first flatten our plate, right? Then create a sketch, then cut our required portion, okay? And then again, we fold it. Okay, so this is the process of the bending, right? Now, next thing is, I want to assign chamfer and fillet. Okay, same already we studied in part modeling. I want to assign chamfer and fillet. So here we have the option close corner, welded corner, break corner, corner, trim. Okay, and then last one is the corner relief, right? So here we have the option, these four options, but I want to assign only fillet and chamfer. So which one we required? So we require here a break, corner, corner, trim. So I select a break, corner, corner, trim. Come on. So here you will get option chamfer and fillet, right? Here you will get option chamfer and fillet. If I click on the chamfer and click on this edge, okay. So here now we don't have the option like angle distance, distance, vertex, okay. Or in fillet already we studied full round fillet, fillet, okay, face fillet. So these options you will not get. Here it's a very simple. You select an edge, but where which edge you have to select? Okay, if I go to break corner again, so here you have to select such a edge. Okay, it's a break means you cannot. If I click on this edge, okay, still he will select this edge only. You cannot assign the chamfer for this edge. Okay, we will assign only for this edge. Okay, so if I click on the close corner again, so I select this edge. Now here you will get a symmetry. Means from this edge to this point it's 8 mm. From this edge to this end point you will get 8 mm. Okay, if I click on OK now, so you will get a such a chamfer. Okay, same I want to assign the fillet. Okay, so I'll select here fillet. Now you will get a radius. Okay, so this is difference. This one is the chamfer and this one is the fillet. Okay, so this is the difference. Okay, the next one is the sketch bend. Okay, now I will remove all the, or I will keep only my Okay, now I will. Okay, so I don't want to add the extra flange or extra sheet metal. I want to only a bend. Okay, I want to only a bend in existing plate. Okay, suppose I want to bend from this inclined line. Okay, I want to bend my existing plate. I don't want to add extra flange. So in such a case, go to sketch, select surface, and click on the line and which portion you want to make a bend. You can create a straight line, inclined line, it depends on your requirement. Okay, suppose if I click on incline, okay, so in this direction I want to bend. Okay, I want to bend this portion, not this portion. Okay, you have the option, you can change or even you can bend this portion also. Okay, I want bend this portion, not this one. So in such case, I will go to sheet metal, select sketch bend command. Okay, select sketch bend command. So when you select command, you will get a message, a planar face on which to sketch the bend line. So this line work as a bend line or an existing case to use for the feature. So already we create a line. So this line will work as a bend line. So just select this sketch. Okay. When you click on the sketch, you will get these options: bend parameter, bend positions, angle, okay, custom bend allowances. So this one. Now here what you have to select, a fixed face. Which face you want? You don't want to bend. I want to, I don't want to assign a bend for this portion. Okay. Okay. So when I click on the fixed face, okay, so software will automatically bend your required portion. So now here we have the option to change the angle. Okay, so if you see this angle is a bend line, this one is our fixed face and this one is bend angle. So in opposite direction you will get a degree, it's a 55. So here we have the bend positions, bend center line, material inside, material or bend outside, and this one is the outside and bend, sorry, it's a, this one is the material outside and this one is bend outside. Okay, if I click on now bend inside, okay, so the bend will start from inward. If I click on the material outside, so bend will start from this bend line. If I click on bend outside, okay, so this will create, or this starting point starts from your bend line. Okay, so these are the some. If I click on now okay, so if you see, we have not added extra plate. Okay, we just bend our existing bend. Okay, so if I click on now edge flange and click on the edge, so this will add extra flange or extra plate. Okay, so this one will work as to add extra flange, but this one is work as a existing bend. Okay, so this is the difference. Okay, the next one is the jog. Okay, we will see this jog and we will solve some one or two examples on these sheet metals. Okay, so in now I will not create. Okay, you can create a bend line in angle or in straight. Okay, but for your understanding purpose, I create a line which is perpendicular to this plate. Right. Now if I go to sheet metal and okay, click on the job and click on a face on which to sketch a bend. Okay, so already we have this bend line. Okay, so when I click on the created sketch, okay, so you will get here a fixed face options, or these options you will get when you select a line. Now if I click on the fixed face, okay, and click on this fixed face, so I don't want to move this surface, so work as a fixed one. So now if you see, you will get a one bend, then straight portion, again bend, and again straight portion. Okay, so this will work as a, or he will create a Z portion. Okay, so he will create a Z portion. So here we have the option dimension positions. So this one is a outside offset. Outside offset means it's a 10 mm, 10 mm from this top side to this top side. If I click on inside offset, inside offset means this surface, this blue portion to this bottom surface. Then overall dimension means from top to this bottom. Okay, it's a total height. Same job positions. Okay, so you will get, if you want to add angle, okay, suppose if I mention here 120, okay, so here you will get a some inclined position. Okay, if I increase the gap, okay, if I increase the gap, so that you will get a this height. If I click on now OK, okay, so that you will get a such a zigzag or Z like profile. Okay, so this one is a, if you have the existing plate and if you want to add bends in existing, so you have the option to jog and sketch bend. If you want to add extra flanges, so we have the option edge flange and miter flange and hem. Okay, so these are the some exercises or features. Okay, so we will take a 5 minutes break. Okay, and then we will solve some exercises. Okay, so sir, just a request to just stop the recording for 5 minutes. Then we will start the exercises on sheet metals. Okay, so just wait for the 5 minutes, or you can just take a break. Okay, so now I want to create this sheet metal part, right? So now just tell me how much thickness we required here for creating such a sheet metal component. How much we required? Okay, so here if you see this one, so here we have a 0.5 mm thickness. So from 3D view you will get it's a complete bend, it's a 90-degree. So for base, first I want to create this base. Now tell me the distance. It's a outside dimensions, it's a 20 by 50, it's a distance. Okay, so I will delete this one. Click on new part, click on OK. Okay, click on show. Okay, click on sketch. Okay, and sorry, first I have to convert the dimensions into millimeter. Select sketch, select plane, and click on or create a rectangle. How much? It's a 20 by 50. Okay, 20 by 50 we required, right? Now exit from sketch. Now how much thickness we required here? It's a 0.25, sorry, 0.5. So go to sheet metal, click on base flange, and just select a rectangle and assign your thickness. How much thickness we required? We required 0.5 mm thickness. So just click on OK. So that you will get this bottom. Now I want to create this bed. Okay, so which command we require here? So we want to add one flange on edge. So select a edge flange. If I click on edge flange, okay, and assign the height. Now tell me the options. Okay, which features or which options we have to select. Okay, so flange length, outer virtual sharp, then inner virtual sharp, and tangent bend. So if I go to sketch, so if you see, it's a perpendicular or it's a distance 20. Okay, it's a distance 20 from outer to outer. Means I will select here my first option, outer virtual sharp. So he will consider the distance from this bottom edge to top edge. How much we require? Yes. Okay. So we how much we require? We require 20. So we will assign here a 20 mm height. Okay, how we know it's a 20 mm? So if I go to sketch again, so in side view, you will get a height from bottom to top. Means it's a base, bottom side to this top side is a 20 mm, right? Okay, so you will get here option this one. Next one is the flange position. We required inward, outward, okay, offset. So I will go to sketch and check it's inward or outward. Okay, so it's a 20 mm, it's a outer distance. Means bend we have to start from internal. If this line, okay, so this line mentioned in internal edge, okay, this dimension is mentioned on internal edge. So the we can consider it's a bend will start from outside, but it's a 20, it's a outer dimension. So we require bend inside. So now click on OK. Okay, simple. Then next one is I want to create these holes. Okay, I want to create these holes. So what I'll do, go to sketch. Okay, select surface. Okay, and create a circles. Or what I'll do, I will create a one. Okay, so I'll create this one. The diameter for this one is a 3. How many circles we required? 8. The diameter is a 3. Now I want to constrain this circle center, because if I pick this point and if I just drag it, this will. So the distance is from this edge to the center, it's a 14. In vertical, in horizontal, it's a 4. So from this edge to this point, we require 14. Right, 14. Right. And from this edge to this one, we require 4. Right. Now exit from command, select feature, and just go to sheet metal again and just extrude cut. Okay, so it's a throughout. So I mentioned here thickness 0.5. Okay, now same, I want to create a pattern type. So go to feature, select patterns. Which pattern? Linear pattern. Why linear pattern? Because of we have the dimensions in X and Y. So I select a linear pattern, features and faces. Which features you want to remove or assign? This hole in X direction. Okay, so I'll select this edge. Okay, so in these directions, how many circles we required? We required 4. Okay, the distance between center to center, it's 8. Okay, now say assign direction 2. Okay, how many circles we required? 2. The distance between this center to this center, it's 8. Right, just click on. Okay, so they will get this holes. Now I want to remove this slot. Okay, so this slot, it's a 10 by 5. So go to sketch, select surface. Okay, so create a slot portion here. It's a straight slot. Okay, so we create a slot. The distance, okay, so it's outside distance 10 and it's a 5. So select a smart dimensions from this edge to this edge. Okay, so it's a, we know it's a 5, means it's a 2.5. Right, it's a 2.5 radius. So I will add, it's a 10. Okay, so 10 minus 5. So I will assign here a 5 mm gap. Now from this edge to this one, we require 5. Okay, so we assign dimension for this slot, but I want to now constrain this one. So which one we have? We have 3 mm from this side. Okay, now 5 mm from outer edge. So I have the option to select from this point to this point. Now tell me how much we require. It's a radius 2.5 plus 5. So means it's a 7.5. right? It's a 7.5. So now exit from command and just go to sheet metal and use extruded cut. So you will get this cut. Now, next one, I want to cut this portion, 50% rectangle on upper edge and 50% on bottom edge or bottom surface. So what we have to do? We have to first flat our existing bed. So what we have option? We can use directly flatten because of we don't have any another flange. But practically, go to in process. First unfold this one, fix one. Which one? This one we want to fix. Then bend to unfold. Which bend we want to unfold? This one, and click on OK. Okay, so there you will get this one. Now create a cut on this edge. Okay, so select this surface, click on rectangle. Okay, so we create a rectangle. Now what are the dimensions of the rectangle? Okay, so it's a height, it's a 5. Okay, then from this outer edge it's a 6.87. Okay, it's a how much? It's a 5, right? Okay, then next one is from this bottom edge, it's a 9, means from this edge to this edge, we require 9, right? Then next one, in this direction, we require 6.87 from this edge to this edge. It's a 6.87. Okay, then next, in these directions, we require 3 mm gap. Okay, so now if you see, our sketch is now fully defined. Exit from command and just extrude cut it. And just click on OK. So you will get a cut. Now again fold it. Just click on bend. I want to unfold. Okay, so if you see, you will get this cut. Now the last one is I want to add this portion. Okay, I want to add this portion. So what do I have to do? Click on edge flange, select edge in this direction. Okay, so how much height we require? Okay, so we required height. So from internal edge, it's a 5 plus it's a radius. Okay, so this one. So you will get a dimensions from this edge to this one. It's a 10. Okay, so I will assign here a distance of flange length 10. Right. Then we want to assign a distance from this edge. So I will select a inner virtual shaft. Okay, so you will take a distance from this edge, not from this edge. Then, but we don't want to add flange on throughout face. So what we will do? We will go to edit flange profile. Okay, edit flange profile. Click on point. Just drag it. Okay, in both directions. Okay, but how we know from the distance? Okay, so we know the distance from this edge we require 25. Okay, so circle we required on 25. So 25 minus 5. Okay, so means from this edge to this one it's a 20. So I'll go to smart dimensions, select edge, this line, and assign a 20. Right? Next, how much we require this portion? We require 10 because of, okay, how we know it's a 10? Because of, if you see this radius is a 5. So it's a total you will get here 10, diameter 10, click on back. Okay, so you will get this portion and click on OK now. Okay, in last, now I want to remove these sharp corners. Okay, so we know that its radius is a 5. So go to break corner trim command and select these edges. This one. Okay, how much we require here? Radius 5. So just click on the 5, enter, and click on 2 edges. Okay, so they will get such a bend. So at the center, we require the whole diameter is a 5. So go to again sketch, select surface, select circle, create your required circle, assign dimension, it's a 5. Okay, exit from command and just remove this portion by using extruded cut. Okay, so like this one you have to complete your sketch. Okay, so these are the features we have used for this part. Okay, so hope so all of you understood. It's a very basic. Here you don't have to create a sketch. Okay, just it depends on your selection. Okay, so only some portion is remaining. Okay, so the tomorrow we will complete these remaining features and one exercises. Okay, so don't be absent for tomorrow session. So we will complete the sketch sheet metals on tomorrow session. In tomorrow session, okay, with examples. Okay, still if you are having some doubts, so for doubts we will take an extra session. Okay, so up to this one, just see these features, do a practice, note down your problems, okay, or selection, okay, or your errors, and we will discuss on one by one. Okay, so only some portions, only some features are remaining in sheet metal. Okay, then we will go to drafting. For drafting, we don't require more than 2 sessions. Okay, because of in drafting we don't have to create a part. In drafting, what we have to do, we have to just convert 3D to 2D. Okay, just make a views. Okay, so just it's only a drag. Okay, so select front view, drag, you will get a side view. If you drag in incline, you will get isometric. If you incline in particular angle, so you will get another view. Okay, so these are some exercises. Okay, so I will share this sheet metal exercises with you. Do same problem. Okay, same problem, and just complete it. Okay, and during this exercises, if you are getting some doubts, just note down it. We will discuss it. Okay, so we will meet in next session. So I will stop here. So good night to all of you. Okay, just do a practice. So tomorrow on same timing we will meet and learn new features of the sheet metals and one or two exercises on sheet metals. Okay.